Pre-statistics. Using systems to model data, Part 2. Lesson objective. Use substitution or elimination to make predictions about situations described by a table of data. Example 2. The data below is the world record times for the 400-meter run for men and women. Construct a model for the winning time for women, labeled W of T, and a model for the winning time for men, labeled M of T, where T is the number of years since 1900. For women, our first step is to put the data in List 1 and List 2. Once the data is in, we hit Stat, right arrow, number 4, which is linear regression, and we have the line of best fit, where the slope is a negative 2.7 and the y-intercept is 70.45. It's always a good idea to see how well the line fits the data. So we can look at this graphically by using the stat plot. So we hit second y equals, which is stat plot. We make sure the plot is on, and for the type we want the first one, which is a scatter plot. Make sure X list is list 1 and Y list is list 2. Then we hit zoom, number 9 for zoom stat. And we have our scatter plot. Now this is roughly linear. We'll see how well the line fits this group of data points. We hit the Y equals. We type in our line of best fit, and then we hit graph. So the line is doing a relatively good job of modeling this data. So the equation for the winning times for females is negative 2.27 T plus 70.45. For men, we enter the data in list 1 and list 2. We go to our linear regression command, and in this case the line of best fit for men is a negative 0.053 plus 48.08. To see how well this line of best fit fits the data points, hit second y equals, which is stat plot. We make sure it's on. Our X list is list 1, our Y list is list 2. We need to hit zoom and number 9, zoom stat. Then we hit the y equals. We type in our line of best fit, and here we have the line of best fit with our scatter plot, and this line is doing a very good job of modeling the data. So the equation for men would be M of T equals negative 0.035 T plus 48.08. Now that we have our two models, we want to predict when the women's record time and the men's record time will be equal. Now the easiest way to do this is by substitution. So we're going to take this expression and set it equal to this expression and solve for T. So here we have our equation. We have T's on both sides. I'm going to add 0.053 T to both sides, and then I'm going to subtract 70.45 to both sides. Now combine like terms, and our last step is to divide by negative 0.217, and we see that T is approximately equal to 103.09. Substituting 103.09 into the equation and solving for R, we see that R is approximately equal to 42.62. According to the model, the world record times for both men and women will be 42.62 seconds and about 103 years after 1900, or in 2003. To verify this by graphing, we go to the y equals. We type in the equation for men and women. Make sure our stat plot is turned off. Next, we hit the window button. For X men, I'm using a -1 so I can see the y-axis. My X max is 125. because the x-coordinate is about 100, and I'll be able to see the point of intersection on the graph. I'm counting by fives. For my y-min and my y-max, I'm using 40 and 50. I know that the y-coordinate of the intersection is between 40 and 50. This is my graph. To use the intersect feature, I hit second and trace, number 5, and we see that the calculator tells me the intersection point is approximately 103.09, comma 42.62. So we have verified the solution by graphing. So even though the model predicted when these two models will be equal, this did not occur. We had a model breakdown. In 2006, the women's record time was still 47.60 seconds, and men was 43.18. So sometimes this happens when we try to model the pattern of data. Sometimes the pattern changes. Example 3. The average annual U.S. per person consumption of chicken and red meat in pounds per person is described for various years in Table 24 on the next slide. So here we have the years. This is the average annual consumption of chicken, and this is the average annual consumption of red meat. A. Let C of t be the average annual consumption of chicken, and R of t be the average annual consumption of red meat, both in pounds per person, in the years that is t years since 1970. Find the equations of C and R. B. Use substitution or elimination to predict when the consumption of chicken will equal that of red meat. What will be that consumption? C. Use the intersection feature on the graphing calculator to verify your work. A. We first need to put in the data into our list. We hit the Stat button, then Enter. In List 1, put the years since 1970, and List 2 will be the chicken, and List 3 will be the red meat. Next, we hit Stat, the right arrow, then Linear Regression. Now, because we are using both List 2 and List 3, when we paste our Linear Regression command in our home screen, we want to first do chicken, which is List 1 and List 2. So we need to type List 1, which is second number 1, comma, second number 2. You should get this equation. If we round this to 2 decimal places, we say C of t equals 1.01t plus 23.38. The equation R of t will be found by hitting the Stat, the right arrow, and then Linear Regression. This time we need to hit second number 1 for List 1, comma, second and number 3 for List 3, because this is where the red meat data is in List 3. You should get this equation, and rounded to 2 decimal places, we can say R of t equals negative 0.63 t plus 130.85. B, we take R of t and set it equal to C of t and solve for t. So we're using substitution. So we have this expression equal to this expression. The next step, I want to add 0.63x to both sides and combine like terms. Next, I want to subtract 23.38 to both sides. I'm left with this equation. And finally, we divide by 1.64, and we get x is approximately 65.53 to 2 decimal places. Now we take 65.53, substitute it back in one of the original equations, and doing the computations, you should get 89.59. So the solution to this system is 65.53 and 89.57. Now, what does this mean in the terms of the problem? We would say, according to the model, in the year 2036, That's 1970 plus our t, which we're going to round off to 66, will give us 2036. The annual per person consumption of chicken and red meat will be the same. For consumption, we would say, according to the model, the annual consumption of chicken and red meat in 2036 will be about 89.6 pounds per person. C. We hit our y equals. We type in our equations for C of t and r of t. Hit window, and I'm using a min of -1 so I can see the y-axis, an x of 90 because I know that the x-coordinate is about 65. I want to count by fives. For the y-min and the y-max, I'm using 80 and 100 because the y-coordinate was close to 90. And I'm counting by ones for the y. I hit graph, and this is my graph. Here's the point of intersection. I'm going to use the intersection feature, and we see that the calculator tells us the intersection x is 65.53 and y is 89.57. So we have verified the answer with the graph. Thanks for watching.